Hi, this section is one of the most interesting topics for me, and we will learn about things that you may already know about this, but you don't know actually why we are getting this. And it is related to the areas, volumes, the one dimension, two dimension, three dimension. So, what we're going to do is that we will tie up all these topics together and define and derive certain things, and we will use the same idea and then extend it to the ideas of circle itself. So no further ado, we shall get into the topic. We shall begin with the idea of dimensions. And for that, let's say I'm having a small point here. Now, can you tell me what is the dimension of this point here? When you look closely, you can say that yes, I can move a little bit up, little bit down, and left and right, but generally we consider the one point or a point as zero dimension or dimensionless quantity. And let's say I am repeating the same point infinite number of times. That means like this. And we have seen this idea in one of the videos before. So it's the same thing. I'm repeating the point infinite number of times. So what am I getting? I am getting a line there if I join them, or I'm having again small points in between them, and thus I form a line. So in a line I can move forward or backward. That is the only possible motion. That's why a line is considered to be one dimensional motion. Only in one dimension I can move. Here I can move forward or backward. So here I'm having a line, right? And let's assume that the length of the line being L there. Now what we're going to do is that we will repeat the same line infinite number of times towards up direction or towards the top. And on the first case, what have we done? We had a point and we repeated the point infinite number of times, and I got a line. Now the same line, again that is also points that I'm repeating, but for the better understanding, the same line I am repeating infinite number of times towards the top. That means like this. I'm having lines like this. Okay, again there is small lines here, but I'm not drawing that. There are infinite number of lines like this. And let's say that is being extending to a width of B. So again, I had a point. I am repeating an infinite number of times to get a line. And the same line, I am repeating infinite number of times to a length of B. Now, what is the shape I'm having here? Isn't this a rectangle? Yes, it is a rectangle, and we have already studied about the area of a rectangle. Area of a rectangle is what? It is length times width. So why it is L times B is because I'm having the line L here that is being repeated to a height of B. That's why I'm having the area of a rectangle as L times B. I hope this idea is clear. Now we are going to use the exact same shape, and then we will get into the idea of volume. And what we're going to do is that here I'm having a rectangular portion, right? Now this exact same rectangle is being repeated infinite number of times or stacked one over the other towards this direction in 3D or towards this space. So what I'm going to get? I'm going to get a 3D shape, or I can say that I'm getting a rectangular box or a cuboid in that case, and that is 3 dimension. And in this 2D, I can move in 2 direction, and this is nothing but 2 dimension. I can move left, right, forward, backward. That is the only motion I can move, and that's why it is 2D. And in the case of 3D, I'm also having, or I can also move up and down. That's why it is called as 3D. I can move in 3 dimensions. So what have we studied here is nothing but I had the point, I repeated infinite number of times to get the line, and then the line I'm extending it infinite number of times to a width of b, and then I'm getting a rectangle. Now the same rectangle I'm stacking up over it to get a 3D shape, that is the rectangular box or cuboid itself. Now it's all about the volume part. Volume of a 3D shape. In the case of area, it was the length that was repeated to a height of b. That's how I got L times b. Now in the case of a 3D box or a rectangular box, isn't it the rectangle that is being repeated to a height of h? I'm assuming it has h, and let's draw the same figure here. Okay, this is my rectangular box, and this is same as L and b, and I'm assuming the height as h. So this same rectangle, that is this portion, that is getting repeated or stacked one over the other to a height of h. So the area is being repeated to a height of h. So the volume would be a times h, and that is equal to, what is area of a rectangle? That is L times b, and that's how I'm getting the volume of a cuboid as L times b times h or LBH. I hope this idea is clear, and for all regular shape, it's going to be exactly like this. I will be having a basic shape. That basic shape will be repeated to a particular height or particular distance, and from that I can find out the area and volume like that. So now what we are going to do is that we are going to use the exact same logic of stacking up of things one over the other to the part of circles. So we will get into that. Now what we are going to do is that we are going to derive the equations related to cylinder, like the volume of a cylinder, the lateral surface area of a cylinder, and the total surface area of a cylinder. All those things is what we are going to do now. Now we will derive all those equations based upon the same circle itself. Why? Because cylinder is nothing but a stacking up of circle itself. For example, think about a coin. A coin is a circular shape, right? So I'm having a coin here and stacking one more coin above it, one more coin above it, one more coin above it, one more coin above it. So the shape is going to be what? The shape is going to be a cylinder at the end. So isn't it the circle that is stacking up to a height of h to form a cylinder? Yep, exactly. So we will see the different equations that is related to the cylinder itself. Okay, so now I'm having a cylinder here with the height as h and the radius as r here. Now if I look closely, I know that the cylinder is nothing but the repetition of my circle here. Infinite number of circle is being repeated like this or stacked over it to form this entire shape that is a cylinder. Now the first thing we will see the areas, okay, the areas related to the cylinder itself. So area. So in the case of a cylinder, there are basically two types of areas. One being the lateral surface area. Lateral surface area means the area that surrounds the cylinder, the surrounding area of a cylinder. That will be my lateral surface area, and then I will be having the total surface area, because if I look closely, there is two portions for this cylinder. One, the curved surface, the surrounding portion of the cylinder, and I'm having two circles, that is above and below. So I'm having two surfaces, the lateral surface and the top and down circle itself. So I have to add the circles area also to find out the total surface area. So first one, the lateral surface area. The lateral surface area. And here also we will derive the equation. We won't be by hurting the equation. So lateral surface area. So we have seen that in the case of the rectangle, it was the length that was repeated above, right? And thus I got the equation as L times height. Now, in the case of lateral surface area, what is getting repeated? If I look closely, the surrounding portion of a cylinder is what? Isn't that the circumference of my circle? So in the case of a cylinder, the lateral surface area, the surrounding surface area of a cylinder is nothing but the circumference of the circle that is being repeated up to a height of h. The circumference of a circle that is being again repeated, that is what is forming the lateral surface area. So what is the length of my circumference of a circle? That is 2 pi r, right? So that is 2 pi r. Now this 2 pi r circumference is repeated up to a height of h. So times h. So 2 pi r h would be my lateral surface area. Now next one, the total surface area. Total surface area. Surface area would be the sum of the lateral surface area, that is 2 pi r h plus the two circles, the area of two circles, and I know the radius of the circle is r, so the area of a one circle would be pi r squared. Since I am having two circles, it will be 2 pi r squared. So it will be 2 pi r squared. This is enough, but you can actually simplify or you can factorize this one, like I can take the 2 pi r as common. So 2 pi r as common. So inside the bracket I will be having h plus one more r. So you can also write the equation like this, no problem in that. So that's all about the area of a cylinder. Now moving on to next one, that is the volume of a cylinder. Volume of a cylinder. Now on the previous case, when we consider that rectangular box, it was the rectangle that was repeated to a, or that was stacked over to a height of h. In this case, it's the circle that is being stacked up to a height of h. Okay, I will just denote that portion here. I'm having infinite number of circles like this stacked one over the other. So the basic idea is volume equal to the area of the basic shape that is repeating to a height of h times height. And what is the area of the base shape? That is my circle, and the area is pi r squared. So that is pi r squared, and h is the height, h. So that would be my volume of cylinder. Now if you know the idea of how we got this equation by stacking up of a basic shape infinite number of times, you don't need to by heart the equations of pi r square h or 2 pi r h. You can all derive right at that moment itself. It's very simple, and this is not only applicable for the cylinder but is also applicable for different shapes that we will discuss on the coming videos. So that's all for today. On the next video we will see the same idea of stacking up of circles on the case of spheres. So see you there. Take care. Bye.